All right, let's jump right into Chapter 5 of the Ganita Prakash curriculum, Parallel and Intersecting Lines. Now, I know geometry can sometimes feel a bit, well, abstract or intimidating when you're just staring at a textbook, but honestly, it's really just a fantastic guide at mastering the visual building blocks of our entire world. So in this explainer, we're going to break it all down.
So let's kick things off with a pretty fundamental question. What happens when lines meet on a flat surface? And maybe more interestingly, what happens when they don't? It sounds almost like a philosophical riddle, right? But the answers to this actually unlock these beautiful, highly predictable patterns that govern everything from the piece of paper on your desk to the massive architectural structures outside your window.
Here is our quick roadmap for today. 1. The geometry puzzle begins. 2. When lines collide. 3. The lines that never meet. 4. Enter the transversal. 5. The magic angle rules. And 6. Prove it yourself. We're going to demystify this whole thing step by step.
Starting off with Section 1, the geometry puzzle begins. Setting the stage on a flat plane. For our purposes today, a plane is just a perfectly flat surface, like your desk or your digital screen.
Moving right into Section 2, when lines collide, exploring intersecting lines and their rules. Now, what's really fascinating here is the strict precision of it all. When two straight lines meet, they don't just sort of vaguely bump into each other, they crash at one single solitary point. And this collision always, without fail, creates exactly 4 distinct angles right around that point of impact. Unlocking this specific puzzle really means understanding the secret mathematical relationships between those 4 angles.
So let's break down those relationships, shall we? We basically have 2 primary types of angles formed by these intersecting lines. First up, vertically opposite angles. Think of these as sitting directly across the intersection from one another, just staring each other down. And the golden rule here is they are always equal. Literally, if the top angle is 120 degrees, the bottom angle is strictly 120 degrees, period. Second, we have linear pairs. These are angles sitting right next door to each other, sharing a straight line.
And that idea of sharing a straight line brings us to a massively important number, 180 degrees. You're going to want to cement this number in your brain. A linear pair will absolutely always add up to exactly 180 degrees. So if one angle in the pair is 120 degrees, the angle right next to it has to be 60 degrees. Together, they combine to form a perfectly flat 180-degree straight line. It's just a perfect balancing act.
But hey, what if the collision is completely perfectly balanced right from the start? Well, that gives us another magic number, 90 degrees. This brilliantly illustrates the special case of perpendicular lines. This happens when the intersection is so totally upright and perfectly squared off that all 4 resulting angles are exactly 90-degree right angles. No obtuse or acute angles here, just 4 perfect 90-degree corners.
All right, on to Section 3, the lines that never meet. The nature of parallel lines.
By definition, parallel lines, which you'll often see written in shorthand with 2 little vertical bars, are lines on the same plane that never, ever meet. Seriously, no matter how far out into infinity you stretch them, they won't touch. To ground this abstract idea in the real, physical world, just picture a long, straight stretch of railway tracks, or even the opposite edges of your smartphone screen. They maintain that exact same distance apart, forever.
Let's hit Section 4. Enter the transversal. The ultimate crossover event.
So, I have to pose this slightly dramatic question to you. What happens if a third line just crashes through them both? Imagine those 2 perfectly peaceful parallel lines suddenly being sliced by a rogue third line. It is the geometric equivalent of a major plot twist, and it's exactly what's going to unlock the tools you need to solve the most complex diagrams. The answer to that twist is the transversal. By definition, a transversal is simply a single line that cuts across 2 or more other lines. When this line crashes through our parallel lines, boom, it creates a very specific puzzle of exactly 8 distinct angles across 2 intersections. And because those 2 original lines are parallel, some truly magical, mathematically perfect rules emerge.
Which leads us directly into Section 5, the magic angle rules, decoding the 8 angles of a transversal.
You can really think of these rules as your ultimate geometry cheat codes. When a transversal cuts parallel lines, specific spatial patterns just jump out. First up, we have corresponding angles. These sit in the exact same corner position at the top and bottom intersections. The rule? They're equal. Then we have alternate interior angles.
These sit between the parallel lines, but on opposite sides of the transversal, often forming a little Z shape. Their rule? Also equal. It simplifies the whole puzzle immensely. If you know just one angle, you can usually figure out almost all the others, simply because so many of them are equal to each other.
But wait, don't fall into a very common trap here. Co-interior angles, meaning the interior angles sitting right next to each other on the same side of the transversal, are the major exception. They are not equal. Instead, they always add up to 180 degrees. Just like our linear pairs from the very beginning, they work together to form a complete 180-degree sum.
Let's wrap up with our final section, number 6. Prove it yourself. Geometry with simple paper folding. Because honestly, you shouldn't just blindly trust a textbook.
I highly encourage you to try this out yourself later. Just grab a piece of scrap paper. Step 1, fold it to make a crisp, perpendicular crease. Step 2, now using that exact crease as your baseline, fold the paper again to make a second perpendicular line. Step 3, unfold the whole thing. What you have just revealed is a brand new line perfectly parallel to the first one. Why does this work? Because you physically created two 90-degree corresponding angles, and as we just learned, if the corresponding angles are equal, the lines are absolutely guaranteed to be parallel. You literally constructed parallel lines with your bare hands.
And that brings up a fantastic point from the curriculum. Geometry is just like learning a new set of tools. Once you know these predictable rules, you can solve all kinds of geometric puzzles. It is a wonderful reminder that there's no real magic to geometry. It might look complex on the page, but it's really just a highly reliable toolkit made up of 180-degree straight lines, 90-degree right angles, and equal opposite patterns.
So I'm going to leave you with this final, provocative thought and challenge. Look around the room you're sitting in right now. How many parallel lines, transversals, and hidden corresponding angles can you find just hiding in plain sight? Maybe they're in the window frames, the floorboards, or the bookshelf. Apply your brand new geometric toolkit to the real world. I promise, once you start looking for them, you won't be able to stop seeing them everywhere. Thanks so much for joining me to explore the fascinating rules of lines and angles. Keep learning, and I'll catch you on the next explainer.